Hi, welcome back. Where are all these volcanoes? We've touched on this maybe a couple of times, sprinkled in when we're talking about plate tectonics. In general, we can say that most volcanoes, just like most earthquakes, are located at or near plate boundaries, but that's not always the case. In general, that's true. So let's try to get a little bit more specific. Again, most volcanoes are near plate boundaries. Mid-ocean ridges at oceanic divergent boundaries produce an estimated 75% of the annual output of magma on Earth. So 75% of erupted material happens on the ocean floor. So most volcanic eruptions we don't see. They're typically at these divergent boundaries. This is typically basaltic magma, very runny, very flowy, not very explosive. So these divergent boundaries is where 75% of kind of the stuff that comes out of the earth is located. So we don't even notice it. We don't see it. This is deep below the ocean. However, convergent boundaries are areas that contain the most active volcanoes. Excuse me. The ones that we can see, definitely convergent boundaries. Approximately 2/3 of all active volcanoes are within the Ring of Fire. Touched on that again when we were talking about plate tectonics. But the Ring of Fire or the Circum-Pacific Belt kind of goes around the Pacific Ocean, starting from South America up North America into Russia, down through Japan, through some of the Pacific Islands, on down past New Zealand. So 2/3 of all active volcanoes on Earth, that are above ocean level are right here. All right here, along the Ring of Fire, as it's known. And as you notice, it is mostly convergent boundary. So this kind of reaffirms that. So along the Ring of Fire, you have all these volcanoes. There are volcanoes in other spots of the world, including some hot spots. But most volcanoes that you're going to find, as well as earthquakes, are around convergent boundaries, and specifically the Ring of Fire around the Pacific Ocean. Now, there are different types of volcanic activity. And we'll get into some of the different types of volcanoes in a little bit later. But again, as you can see, along the Ring of Fire is where we find most active volcanoes. However, at divergent boundaries is where most of the stuff that's coming out of the earth is located. So we don't see most of that. But different volcanoes are formed differently. Island arcs are convergent ocean-to-ocean crust, can be very explosive. Continental arcs are convergent ocean to continental crust, so it can be very explosive. Rifting, like what we saw in the basin and range, and what's going on in Africa currently, as continents are being kind of tugged and pulled apart, not necessarily at a divergent boundary, but something's causing them to kind of extend and split. We can get some rifting and some volcanic activity there. Hot spots, for some reason, abnormally hot plumes of mantle bubbling up, melting through the crust, creating volcanic activity. We see that in Hawaii. That's what's responsible for the volcanoes of Hawaii. More on that in just a minute. Also, Yellowstone. So hot spot under the oceanic crust, gentle. Hot spot under continental crust, super explosive. Mid-oceanic ridges, that we find a number of different places on Earth, also more gentle. So it's typically the convergent boundaries and hot spots under the continents that are going to be the most explosive. Now, I've used that term hot spot. Let me kind of define it a little bit. So in the mantle, every once in a while, you just get these weird little plumes, these weird little kind of rising hot batches of mantle that kind of come up and melt the crust as it kind of comes in contact with it. So a little hot spot develops over this weird mantle plume, and magma generated by the hot spot again rises through the crust, produces active volcanoes at Earth's surface. What's interesting is that in the mantle, this hot plume in the mantle stays put, but as the plate is moving over it, you can create a chain of volcanoes. And so, for instance, there's a little mantle plume. So for some reason, we don't know why they necessarily exist. They think it's because a lot of times these hot spots are kind of in the middle of plates, and maybe it has to do with this big plate over this big area of the mantle applying so much pressure that kind of towards the center of that plate, it creates a little hot spot because of the increase in pressure. It certainly matches up kind of shape-wise and location-wise. But if there's some random hotter mantle plume in the mantle, it heats up the crust, causing it to melt. And that melted material, since it's less dense than the surrounding material, hot stuff rises. It comes out of the surface. If it magma below the Earth's surface, if it comes out, it becomes lava. Well, this mantle plume stays put, but if the plate moves over it, so here's volcano number 1. All right, the plate keeps moving. Now volcano number 1 is here. Now volcano 2 is created. As the plate keeps moving, 1 here, 2 here. Now volcano number 3 is created. Plate keeps moving. 1, 2, 3, volcano number 4. Now each of these are getting ground down. Weathering and erosion is kind of eating away at these, and time is eating away at these volcanoes. So they kind of going to get ground down. But these volcanoes are no longer active. Only the one, in this case, when we're talking about hotspots, only the one over the hotspot. That's how Hawaii and its chain of islands was formed. So for the state of Hawaii, there's I think 5 main islands of Hawaii. Hawaii, Maui, Oahu, Kauai, and another one that's escaping me. But if you actually look below the ocean surface, there's not just the 1, 2, 3, 4. There's not just the 1, 2, 3, 4, 5. There's actually a bunch of them all on the surface of the ocean, going almost all the way up into Russia. So all of these were created. These chains of islands that are now below the ocean surface were all created as the hot spot, which was right here as that plate kind of moves over the hot spot. So hot spot, volcano, hot spot again, volcano, plate movement, volcano, plate movement, volcano. So you can follow that chain, and all of those were created as the plate moved over this hot spot. Here's another look at it. So the current mantle plume over Hawaii, you get some erupting volcanoes like Mauna Loa and Kilauea, one of the most active volcanoes in all of Earth. But as you go to the other Hawaiian islands, there is really no volcanic activity because they're not over the mantle plume anymore. They're not getting that, having magma fed up to them. So Maui, Oahu, Kauai. Molokai, is that the one I missed? But in any case, that mantle plume stays put. It's just in this case, the Pacific plate moving over it. Now, there are other hotspots. One of those being Yellowstone. Yellowstone under continental crust is under a hotspot, and North American plate is moving, and there's actually a string of past eruptive volcanoes, in this case super volcanoes, because a hotspot underneath continental crust creates very sticky, very gas-rich rhyolitic magma, which is very explosive. Big, sticky, slow-moving stuff, and when it erupts, boom. But there's actually a string of volcanoes leading up to where the current Yellowstone supervolcano is. But that's just one of many volcanoes in the United States. A number of active volcanoes, the red means active within the past 2,000 years, which is technically active. So we see that on the string of island arcs, continental convergent boundary of Alaska, on down into Washington and Oregon and some in California. The green are potential active volcanoes, and all the blacks are just kind of cities, large city centers. So you can see how large, or how some big cities, like for instance Seattle, are close to volcanoes like Mount Rainier. And if you look in Arizona, obviously we have some large cities, and we have this little yellow area of potential volcanic activity. Arizona, what are you doing? Hawaii, some active volcanoes. I guess there is possibly one on Maui, but as you get to the other islands, they're not over that hot spot anymore, so they're not being fed. No, so really mostly the big island of Hawaii, and maybe on Maui you might get a little activity, but outside of that, sorry, the rest of Hawaii. So there are a number of volcanoes, really nothing else. As you get kind of past the Wyoming and Yellowstone in Wyoming, Bandera Field in New Mexico, as far as elsewhere in the U.S., not so much. So where is the volcanic hazard the highest? Along the Cascade Range, at least in the lower 48. Even though there's a lot of volcanoes in Alaska, no one really lives out there, so it's not a high hazard. And even though there's volcanoes in Hawaii, they tend to erupt more gently. They're not really a big hazard. These ones are hazardous in that they could cause damage, destruction, and death. So all through the Cascade Mountains, places like Mount St. Helens and Mount Rainier, Yellowstone Hotspot, which is a super volcano, more on that. And then we have that rift-related volcanism in Arizona. So in Arizona, we actually have a ton of old volcanic activity we can see. The most recent, I believe, was 1,000 or 2,000 years ago. I think more on that later. But in the Basin and Range Province, and we talked briefly how a number of units back, how plate tectonics shaped the formation of Arizona. But there was the result of the Basin and Range Province was the result of tectonic extension that began around 17 million years ago. So there was movement along the San Andreas Fault, and that movement of the Pacific plate kind of moving up the coast actually started to tug and kind of pull at the North American plate here, causing it to kind of break apart, to be extended and kind of break apart. So the western portion of the North American plate began to thin out as it was stretched, and it began to crack. So as it cracked, that allowed for some magma to rise to the surface in some locations. And if you're cracking the earth, you're releasing pressure, and you're giving the conduit to some magma to kind of bubble on up. So we see a big amount of volcanic activity, believe it or not, in Arizona, even some close to where we're at down here in the valley. So this looks at different volcanic fields from 200 million years ago until today. So the blue are some of the oldest volcanic activity, kind of seen in southern Arizona, 160 to 200 million years ago. Green, kind of a little bit further, kind of closer to Tucson, 50 to 82 million years ago. The yellow, 11 to 38 million years ago, and a lot of that was created during this extensional process. 5 to 16 million years ago, you get even further north, and in the red, 0 to 4 million years ago, some of the larger eruptive areas being in Flagstaff and over near Springerville in the White Mountains. Excuse me. A lot of that, the younger stuff, of the orange and the red, is due to a hotspot developing underneath Arizona. There's really no technically active volcanoes in Arizona at this time, but you never know. So here's Phoenix, here's the 17, here's the 10. Now you can see some dots of stuff, including even some more recent stuff, kind of out past Buckeye and Tonopah's out in this area. So yeah, not too far from us. There's been definitely some active volcanoes looking in and around the Phoenix area. Let's pause here. So that's where volcanoes are located: world, U.S., and Arizona. Now let's talk about the different types of volcanoes and how they erupt. So I'm going to pause here, and I'll see you back in just a minute.